Okay, my closing thoughts on this assignment that just about everybody got now. The probability of getting 3 heads is 1/2 times 1/2 times 1/2, which is 1/8. Somebody put 1/6, which is a common mistake. But 1/2 times 1/2 times 1/2 is 1/8. And so therefore, again, the thought on that, closing this out, if I had 3 coins and I flipped all 3 of them, the probability of all 3 of them landing on heads is 1/8, 1 out of 8 times, okay? So let's see, let me do one more for example over here. The probability of rolling 7, probability of rolling a 7, in order to get a 7, okay, so again, it's 36 different things can happen because there's 6 on this die, 6 on this die. But the probability of rolling a 7 is how many different ways that your desired event can occur divided by that 36. So to get a 7, you could get 1 and a 6, 2 and a 5, 3 and a 4, 4 and a 3, 5 and a 2, 6 and a 1. And again, 1 and a 6 and 6 and a 1 are different because we said at the beginning, think of it as one die being red and one die being white. Even if they weren't, it would be the same thing, but it's more visible, it's more understandable if they're different colors. So you can say, oh, there's a 1/6 and there's a 6/1 when we roll the dice. All right, so there's 6 different ways that we can get a 7. It says 2/5. There's 6 different ways, and so the probability of rolling a 7 would be 6 over 36, which is 1/6. This, by the way, is the most common thing that could happen. If I was fixing to roll the dice and I said, all right, bet all your money on whatever you think it's going to come out to be, everybody in the room ought to bet on 7 because 7 is the most likely thing that can happen. There's more ways to get 7 than there is to get any other things. Oh, by the way, a lot of y'all were doing this. You were like, okay, probability of getting a 1, 0. Probability of getting a 2, 1 out of 36. And then this is like 2 out of 36, which is 1/18. 3, there's 3 ways you can get a 4. There's 4 ways you can get a 5. There's 5 ways you can get a 6. There's 6 ways you can get a 7. And some of you just kept going, like there's 8 ways, 9 ways. No, but that's wrong. When you got to 7, you should have gone back down the other time. So it's like probability of getting 8, because there's only 5 ways of getting 8. Is 2 and a 6, 3 and a 5, 4 and a 4, 5 and a 3, and 6 and a 2. There's only 5 ways of getting 8, so it goes back down. So the probability of getting 8 is exactly the same as the probability of getting 6, 5 out of 36. And then 9 is 4 out of 36, and so forth. And the final answer was 12. The probability of getting a 12, there's only one way to get it, 6 and a 6. So it's 1 out of 36, 1 over 36. Okay, the thought for today is permutations. Permutations, and we've talked about permutations a little bit before when we were talking about, again, the fundamental counting principle is how do you count stuff, and we talked about putting books on a shelf. And so if I had 4 books on a shelf, how many different ways could I arrange those books? And what we said was, you could, okay, if you got one spot, the first spot on the shelf, there's 4 choices for that. And once you choose one of the books to put on the shelf there, then the one next to it, you got 3 choices to put there, right? And so you multiply them, and then there's 2 choices, and there's 1 choice. And so what we talked about was the concept of factorial. This is the same thing as 4 factorial with the exclamation mark right there. 4 times 3 times 2 times 1 came out to be, what, 12 times 2 is 24. So there's 24 different ways that I could arrange 4 books on a shelf, all right? And so this, actually, the concept here is called permutations. And what we have for permutations is that we have a formula. There's a formula for finding the number of permutations. If you want to find the number of permutations of n things taken r at a time, and again, don't get caught up in the n's and the r's and all that other stuff. It's just we have to do some way of making it to where it's going to carry over for everything that we do. The number of permutations of n things taken r at a time is equal to n factorial over n minus r factorial. Okay. Let me show you why that gets complicated like that, okay? For instance, if we were going to take all 4 books and put them in 4 shelves, we would have the permutations of 4 things taken 4 at a time. So 4 things taken 4 at a time, all right? So the formula says to put n factorial, that's 4 factorial, over n minus r factorial. Well, n minus r, that's 4 minus 4, 0 factorial. All right, so let me put another little thought for the day over here, 0 factorial is always equal to 1. 0 factorial is equal to 1. So this goes to 1, so this comes out to be just 4 factorial, or 24. All right, so 4 things taken 4 at a time. Anytime you have just 4 things taken 4 at a time, or 8 things taken 8 at a time, for example, if I ask you to take 8 things taken 8 at a time, that's going to come out to be 8 factorial as well, because it'll come out to be 8 factorial over 0 factorial, or 8 factorial over 1. So whatever 8 factorial is equal to, if you have 8 things taken 8 at a time. All right, so what kind of things are we talking about? Let's talk about some real life stuff right here. Let's say you want to look at the different ways that you could unscramble the words in the letters in a word. So I'm trying to think of a word that doesn't have repeated. So like a flag, okay? Flags, how about more than one flag? Okay, so flags has 5 letters. How many different 5-letter words could I make with the letters of the word flag? Okay, and where words doesn't have to be a real word. It's not one of those games where it's got to be actual word. This is just how many different ways can I arrange the letters to make different words. Okay, for example, let me just do some of them for example here. I could do, switch those last 2 letters and that gets something different. I could put the A and the L different, you know. Okay, so you get the idea. So I'm just taking all the letters. So the idea is we have 5 letters in the word. How many different ways could you arrange those 5 letters? And so what you do is you say, well, again, if you want to do it by hand, you go out like this. You say, okay, I've got 5 different places that I can put a letter. So the first letter, I've got 5 choices. It can be an F or an L or A or G or S. And so you get 5 choices for that. Once you choose one of those, then there's only 4 choices. No matter what you choose, there's only 4 choices left, and then 3, and then 2, and then 1. All right? Let's do it by the formula. The formula says we're taking the number of permutations of 5 things, all 5 letters, taking 5 at a time. And that will come out to be 5 factorial. 5 factorial is 20, 60, 120. Okay, so there's 120 different words that we could have made with the letters of the word flags. All right, here you go. Here's a slightly different problem with the same letters. We still got flags, okay? But now let's say 3-letter words. And again, we're using the word words, you know, loosely here. It doesn't have to be actually a word, okay? So 3 letters. How many different 3-letter groupings can we have with the words, with the letters in the word flags? For example, again, let's just list a few of them and then we'll figure it out mathematically. It could be FLA, just those first 3 like that, or it could be LAS, or it could be FSG. Okay, so you get the idea there. Any 3 of these letters we could take and make another word, all right? So how many different of those can we do? This is when you come in with your formula and you say it's the number of permutations of 5 things taken 3 at a time. Okay, because you've got 5 letters to choose from. You want to take 3 of those letters. So how many different ways can you take 5 things 3 at a time? So this is the formula that you're going to have to know. The number of permutations of n things taken r at a time is n factorial over n minus r factorial. So 5 things taken 3 at a time. Obviously this is n and this is r. It's 5 factorial over 5 minus 3 factorial. Alright, so just learn this formula, figure out what n and r are, and it makes perfect sense because the idea here is this: you don't have as many permutations here as you would have over here because you're only using 3 letters. How many less? Well, it's kind of hard to think about, but it comes out to be divide by 2 factorial, and that's what it comes out to be. So the way we simplify this is that's 5 times 4 times 3 times 2 times 1, or 2 factorial over there. You can just stop when you get to this 2 factorial and divide out that 2 factorial. And so that your answer just comes out to be 5 times 4 times 3. So what's a good way to do that? 5 times 4 is 20 times 3 is 60. Okay, so there are 60 different 3-letter words that you can make with the 5 letters in the word flags. All right? So with this in mind, let's practice some of this. I've got some problems designed for you. I'm going to just give you like, okay, here, figure this out. Permutation of 7 things taken 5 at a time. You should say 7 factorial over 7 minus 5 factorial, which is 7 times 6 times 5 times 4 times 3 times 2 over 2 factorial. And then you just divide out that part, multiply those together like that. Let me give you a slightly different one here. If I give you number of permutations of 8 things taken 7 at a time, you should say that's 8 factorial over 8 minus 7 factorial. Okay, so that's just 8 factorial over 1 factorial. All right, 1 factorial is just 1, so this is just 8 factorial, so you have to multiply all these out. If you have a calculator that does factorial, that's good. If not, you just do a bunch of multiplication like this, okay? So whatever that comes out to be. If you had permutations of 8 things taken 2 at a time, let me show you how you can do this a little bit easier. 8 minus 2. So 8 minus 2 factorial down here is 6 factorial. When you have 8 factorial over 6 factorial, you can do it like this. 8 times 7 times 6, and then you can just stop right here, because at the bottom you have 6 factorial, at the top you have 6 factorial. So this is basically 6 times 5 times 4 times 3 times 2. This is 6 times 5 times 4 times 3 times 2. Well, all this divides out. So you can just stop when you get to 6 factorial, and your final answer is 8 times 7, which is 56, okay? So I think the best thing to do at this point is to give you some problems and let you work on these. And again, we'll do like we were doing before. If you have issues with this, try to work all these problems, turn me something in, and I can comment on it and turn it back to you if you have it. If you have any other questions and all that, you can contact me through the app. But see all this, it says permutations, arrange 6 books on a shelf. Okay, so you got 6 books, you're going to put all 6 books on a shelf. How many different ways can you do it? Here, you want to choose a president, vice president, secretary, and treasurer from 4 people. So you have 4 people, all 4 of them are going to be officers. Find a way to choose class officers for all of those 4, all right? And here, you want to choose the same 4 offices, but you've got 7 people to choose from, all right? So now you have 7 people to choose president, vice president, secretary, and treasurer. Figure out how to do that. Here, make a 3-letter word from the words from flagship, okay? So here's the word is flagship. How many different 3-letter words can you make from that? And again, it doesn't have to be an actual word. And then here's just a practice with the permutation. N factorial over n minus r factorial. 5 things taken 5 at a time, 5 things taken 1 at a time, 9 things taken 7 at a time, and 8 things taken 4 at a time. All right? Good luck. Let's see how you do.